milestone lecture. So before we go on to the details of the talk, let me first provide you a brief introduction. Of course, Professor Chakravorti needs no introduction, but still it is a formality. Dr. Sivaji Chakravorti did his BEE, MEE and PhD from Jadavpur University, Kolkata in 1983, 1985 and 1993 respectively. From 1985, he is a full-time faculty member of Electrical Engineering Department of Jadavpur University, where he is currently professor in electrical engineering. From August 2015 to August 2020, he was the director of National Institute of Technology, Calicut, on lien from Jadavpur University. He worked at the Technical University Munich as Humboldt Research Fellow in 1995 to 96, 1999 and 2007 respectively. He served as development engineer in Siemens AG in Berlin in 1998. He has also worked as Humboldt Research Fellow in ABB Corporate Research at Ladenburg, Germany in 2002. He worked as US NSF guest scientist at the Virginia Tech, USA in 2003 and as guest scientist at Technical University Hamburg-Harburg, Germany in 2005. He is the recipient of Technical University Munich Ambassador Award in 2013 and AICTE Technology Day Award in 2003. He is Fellow of Indian National Academy of Engineering, Fellow of National Academy of Sciences India, and Distinguished Lecturer of IEEE Power and Energy Society. He is presently Vice President of the Indian National Academy of Engineering. He was chairman of IEEE India Council during 2017 to 2018 and associate editor of IEEE Transactions on Dielectrics and Electrical Insulation during 2014 to 2018. He has published more than 200 research papers, including 67 papers in IEEE Transactions, authored 3 books, edited 3 books, developed 3 online courses, and owns 1 US patent, 2 Indian patents, and 2 software copyrights. His current fields of interest are condition monitoring of power equipment, numerical field computation, and optimization of insulation system. Let me provide the brief abstract of the talk that I have with me before the actual talk begins. So this talk is on the first 2 IEEE milestones in India, dedicated in 2012 by the then IEEE President-elect Dr. Peter Staker. In this talk, the details of the IEEE program will be presented starting from its inception. A major point of discussion will be the criteria for obtaining the approval of an IEEE milestone and the process of approval. Historic significance of the first 2 milestones in India will be outlined along with technicalities. Information about the dedication programs held in 2012 will be given along with the press clippings. Finally, the IEEE Milestone Map and the present status of the other IEEE milestones in India will be elaborated. So with that, I welcome Professor Chakravorti to deliver his talk. And after the talk, we can have questions.
Thank you. Thank you very much, Professor Mitra, for very detailed introduction as well as the abstract. Well, let me start the presentation. So now I have to share my file. So shares here. Okay, now hopefully it will come on your screen.
Yes, it has.
It has, right? So I will move on to full screen mode. Is it now full screen mode?
Yes.
Okay, good. Then it is all set. So once again, a very warm welcome on my personal behalf and also on behalf of IEEE Kolkata section for this very special program organized by the present Kolkata section team. And the title that I have made for this talk is IEEE Milestones, the first millimeter wave communication by J.C. Bose and Raman effect. So let me go forward. First, a few words about IEEE milestones. IEEE milestones in electrical engineering and computing program. This particular milestones honor significant technical achievements in all areas associated with IEEE. This is very important. This is a program of the IEEE History Committee. This milestones program was established by IEEE in 1983 in conjunction with the 1984 centennial celebration, and it particularly was targeted to recognize the achievements of the giants who formed the profession and technologies represented by IEEE. These are some of the introductory words, but I would also like to say a few words about the IEEE Global History Network, in short IEEE GHN. This was in September 2008. The IEEE History Committee launched the Global History Network, particularly at the occasion of the IEEE Section Congress in Montreal, Canada. What this GHN intends is to be the world's premier site for the documentation, analysis, and explanation of the history of electrical, electronic, and computer technologies, as well as the scientists, engineers, and also business people. That is an interesting point here, who made these technologies happen. And at the same time, on the history of the organizations to which these men and women belong. That means these scientists, engineers, and business people, these are the men and women who made these technologies happen, but also on the history of the organizations to which these people belong. Now a little bit about the milestone details. The IEEE Milestone Program, as I have already said, honors significant technical achievements in all areas associated with IEEE. Then what are these designated fields? Engineering, computer science and information technology, physical sciences, biological and medical sciences, mathematics, technical communications, education, management, and law and policy. So here, actually, I would like to highlight this point that typically when we say IEEE, the first thing comes to our mind is engineering, and a further narrower vision comes that it is electrical, electronic, computer engineering. But if we look at the domain that this IEEE milestone covers, it is such a wide spectrum domain that it practically covers almost everything. IEEE milestones recognize the technological innovation and excellence for the benefit of humanity. This is the actually the key words of IEEE. And these are found in unique products, services, papers, patents, etc. But very important point that IEEE makes it a very important point, that IEEE honors the achievement rather than a place or a person. This is a very important point to note. Now, who can propose an IEEE milestone? These IEEE milestones are basically proposed by IEEE member, and It has to be sponsored by any one or multiple IEEE organizational units, typically called IEEE OU. This could be sections, this could be societies, this could be chapters, or this could be even student branches. So typically, let's not think that it is only the sections or for that matter chapters. It could be even student branches who can propose IEEE milestones. I would like to show an interesting IEEE milestone map. This was published by IEEE, and I have taken this map snapshot in 2012 when we were actually active in this milestone program. Now, if you look at that in 2012, these are the places where IEEE milestones were already dedicated. And if you look at that, it's very interesting that it will be the US-Canada region on the left. In the middle, it will be the Europe. A few in the Middle East area, but not in the farther west. One in the South Africa, one in Chile, one in Central America, lot in Japan and Korea area. Rest is just blank. And look at India, there was none. So that was one of the focus of the IEEE Kolkata section. Of course, that time it was called IEEE Calcutta section. I mean, not in 2012. The whole thing started earlier in 2010. This was primarily targeted that there were a lot of works which have been done in India and which are eminently suitable for IEEE milestones. So why not do it? And IEEE Kolkata section picked up the two most important work that was done in Kolkata. But before going into those two IEEE milestones, then what are the criteria that we had to satisfy? Because when we propose, these criteria has to be satisfied. Now, to be proposed as an IEEE milestone, an achievement must be at least 25 years old. So this is one important thing, that we should not think that achievement should be very old. It is at least 25 years old. And of course, as I said earlier, benefited humanity. But there is another important part. Must have had at least regional importance. That means it is not necessarily, it has to be a global phenomena, but it should have regional importance. What is regional importance? That IEEE defines that as an area of more than 500 square kilometers. That means this achievement must have had importance or impact over an area of more than 500 square kilometers. And another major aspect is that the achievement which we are going to propose must not be subject to any current litigation. This is very important. Then a question is often asked that whether there is a maximum or minimum number of achievements. For example, whether in any calendar year, is there any number? The answer is no. Similarly, whether any organizational unit, so say for example, IEEE Kolkata section, is there any limit that in a year we can do only this much? The answer is no. Similarly, is there any limit on the number of milestones in any particular geographical area or technical area? The answer is no. So in a way, or in other words, that there is no maximum or minimum number of achievements to be proposed as milestones as long as they are satisfying IEEE criteria. But at the same time, I have to here mention that it is not that we just write something and send it. it has to be proved with authentic documentation. And then what is the process? Of course, once we propose it and once it is sponsored by an operational unit, it goes to the IEEE History Committee. Then IEEE History Committee has certain internal processes. They get it vetted by so-called adjudicators. And when they get unequivocal recommendation from all the adjudicators, then they approve it and then they forward it to the IEEE Board of Directors. And if that is approved, then the bronze plaque commemorating the achievement, again important part, commemorating the achievement, not the person, is placed at an appropriate site with an accompanying dedication ceremony. So I will also talk about this dedication ceremony which happened in Kolkata. But one more point about this plaque, the official IEEE plaque is English language plaque. However, the sponsoring organizational unit, that means whoever is sponsoring it, they can request a plaque at their own expense in other languages. This translation must be made or validated by a third-party professional translator at the sponsoring organizational unit's expense. And one more point I forgot to mention earlier, that at least one of the milestone proposers must be a current IEEE member or student member. So that's what I was trying to say earlier, that not necessary it has to be a full member or fellow or something. Even a student member can propose. So at least one of the milestone proposers must be a current IEEE member or student member. Now I move on to the milestones that we did starting from 2010. The first one is, of course, Sir J.C. Bose. Not that J.C. Bose is the milestone. Milestone is, of course, the millimeter wave experimentation, but it was the work of Sir J.C. Bose. I start with this photograph, which was taken in Sorbonne in Paris in 1926. So it was at the advanced stages of Sir J.C. Bose. But now coming to the IEEE milestone. This milestone is the first millimeter wave communication experiment. This is the milestone. And of course, it was by Sir J.C. Bose. And the time span for this was 1894 to 1896. This IEEE milestone was dedicated at Presidency University, Kolkata, where this work was done. This is also as per a policy of the IEEE. We have to specifically say where this was done and appropriately where the plaque has to be placed, and IEEE approves it. That the then IEEE President-elect, Dr. Peter Staker, he came to Kolkata, and this entire ceremony was organized on September 15, 2012. Now let us look at the J.C. Bose milestone. As I said earlier, IEEE milestone honors the achievement. So this wording that you are seeing on your screen is actually the exact wording of the IEEE milestone approved by the IEEE History Committee. And what it says, let me read it. In 1895, Jagadish Chandra Bose first demonstrated in Presidency College, Kolkata. By the way, this we have to prove by documentation. They asked for all documentation, authentic documentation, which we had to supply to the IEEE History Committee. So Presidency College, Kolkata, India, transmission and reception of electromagnetic waves at 60 gigahertz over 23 meters distance through two intervening valves by remotely ringing a bell and detonating some gunpowder. From his communication system, for his communication system, Bose pioneered in development of entire millimeter wave components like spark transmitter, coherer, dielectric lens, polarizer, horn antenna, and cylindrical diffraction grating. Let me tell you, this is the first millimeter wave communication system in the world we all know, developed more than 125 years ago. And very interestingly, this is the oldest milestone achievement from Asian continent. That means the entire Asia, including Japan. So that's quite an achievement for this entire work done by Jagadish Chandra Bose. Oof. Now, what you are seeing on the screen on the left is a photograph of the bronze plaque. And this bronze plaque was given to IEEE Kolkata section from IEEE. And on the right, what you can see is the actual place where this plaque was installed in Presidency College. So if next time you visit, now it is university, so Presidency University, please don't forget to see this plaque. It is actually installed at a very prominent place in their main building. Now, a little bit about the technicalities, but I would first of all say that I am not an expert on this area of the work, so I may not be able to answer questions which are technical, but I would like to give some of the significance and historical aspects of the work. So first is the choice of frequency by J.C. Bose. J.C. Bose chose quasi-optical millimeter wave frequency range. And the wavelengths he used that ranged from 2.5 centimeter to 5 millimeter. The reason for the choice of millimeter wave by J.C. Bose was primarily due to the advantage of studies of quasi-optical properties of the radio waves within his laboratory of limited size. That is the important point. That means he had to work within his laboratory of very limited site, which was available to him at the then Presidency College. However, the important point here is that the components and the systems developed by J.C. Bose, initially at millimeter wave and subsequently at microwave, were outstanding discoveries made more than 125 years ago in Kolkata, most of which are now being utilized. Whatever he developed, even now they are utilized. However, now they are utilized in a modernized form, and they are even utilized for earth to space links and very important remote sensing applications. So we have to just understand the brilliance of the work done. The experimental research that J.C. Bose conducted in the millimeter wave technology, and that too in the 19th century India, that means 1895, 1897, that particular term. And the system he developed, it could easily be termed the first wireless communication system. Today we talk about wireless communication everywhere. In fact, I am giving this talk or you are listening this talk using wireless communication definitely. And this was probably the first wireless communication system which was utilized in a demonstration of remote control application. In 19th century Kolkata, workshop facility available to J.C. Bose was very primitive compared to the precision that was needed to build a component that should operate at 5 millimeter wavelength. But here is the innovation that Bose demonstrated, and that is just simply awe-inspiring. This is a slide which is showing J.C. Bose's equipment design. On the right, J.C. Bose in 1897 in Royal Institute, London. He was invited by Lord Raleigh, and that time J.C. Bose was quite young. And you see the design which he made. This was, of course, that time there was no sophisticated computer, so these were all hand drawn. So the radiator design on the top left, then the spiral spring receiver design here, and bottom left is the arrangement where we have a lens at the exit of the waveguide. And these mounting stems of A and C, the outer spheres, they were so designed that this could be inclined to adjust the dimensions of the spark gaps. As you can see, there is a gap between A and B and B and C. These are the spark gaps which J.C. Bose used, but he used this stem design in his own lab, whatever he has fabricated, so that he could control the dimensions of the spark gap. This is taken from J.C. Bose's 1897 paper, which is the diagram of the receiver and transmitter apparatus, where you can see on the left R, if you can see my mouse, this is the radiator. Then S here is the spectrometer circle. M here is the plane mirror. F here is the collecting funnel. And instead of the plane mirror, it could be C here, which is a cylindrical mirror. Then it could be P, which is a totally reflecting prism, or it's a semi-cylinder. This K is a crystal holder. V is a voltage voltaic cell. Then we have a rheostat here, and this is the galvanometer. So this was the entire design that J.C. Bose presented in his 1897 paper. And this is the equipment that is today, if we go to the Museum of Bose Institute, Kolkata, that we can see, which is the 60 gigahertz microwave apparatus. Of course, this is pretty well maintained, so now it looks as good as new. But what we can see here is that his receiver on the left here used a galena crystal detector inside a horn antenna and galvanometer, which you can see here, to detect the microwave, which is coming from the right side. And for all these, Bose invented the crystal radio detector, the waveguide, the horn antenna, and other apparatus used for this entire experimentation at microwave frequencies. Some of the Bose's original components. This is the transmitter antenna. You can see the spark gap here, just visible here behind this polarizing grid. And in the background here, you can see is the high voltage equipment that will be used to generate these sparks here. And then at the left, you can see is the receiving horn antenna. These are all these Bose's components. Just look at that, how he made all these in 1895. These are the spark gaps that Bose used. These were mounted inside the transmitting antenna. That means these are the spark gaps here, and the high voltage is supplied from the source. So we get a spark here and we get the wave, that particular signal generated. Then this is the transmitting receiving antenna, the complete setup. You see that transmitting antenna on the left side here. and the receiving antenna on the right, and in between we can have different types of components. Here you can see the prism. And particularly important was this screw, that it is called the adjustment screw on the top of the receiving antenna. It was used to adjust the pressure of the point contact detector. There was a detector here, point contact detector. I would just show a few things about this, a very interesting detector. And in the center, you have the rotating table. This was called the spectrometer circle. And on this particular table, various microwave components like prisms, lenses, the grids, polarizers, they were all mounted for doing the experimental studies. And this is what the point contact detector, that means, as you see here, the receiving antenna had point contact detector within it. So these are the point contact detectors mounted inside the receiving antenna. And these are original Bose's components. Very interesting was the polarization apparatus. And this diagram on the left is Bose's drawing. And then on the right is the actual polarizer that he made. This is original Bose's polarizer. How he did it? This was actually a cut-off metal plate grating consisting of a book. And you know, it was a Bradshaw railway timetable. Bose used a railway timetable with sheets of tin foil interleaved between the pages. I mean, it's just unthinkable that how at that point of time Bose thought of it and made it with a railway timetable. Then the polarizer, the Twisted-Jute polarizer, on the left, it's the Bose's drawing. And on the right, we see the actual one of the Twisted-Jute polarizer that Bose used. Again, once again, I mean, sometimes we feel really humbled by the innovation that was done in 1895 to perform an experiment of millimeter wave and later on microwave. On the left is the Bose's 1897 diagram of the double-prism attenuator, and this is the original double-prism attenuator of the which Bose has prepared. Of course, these are all, if you go to Bose Institute, so I have written acknowledgement Bose Institute, Kolkata, you can see all this. But very important is this one, that Bose's measurement of IV or VI, whatever you say, characteristics of junctions. This is the characteristics curve of the single point iron receiver. The junction consisted of a sharp point of iron pressing against an iron surface with pressure capable of fine adjustment. This is actually this one here, you can see. Here it is like a point, and this is a surface, so this is pressing on this one and the pressure can be adjusted. So Bose performed this experiment where on the x-axis you have volt, y-axis you have ampere. Just look at how brilliantly this was done. What Bose found was very interesting, that the different curves, they were for different pressures. And Bose immediately found that the junction doesn't follow the Ohm's law. And there is a knee in the curve at approximately 0.45 volts. Now, this is probably one of the earliest work which gives us an idea about the semiconductor type behavior. And this was all done in 1897 with this sort of equipment and a galvanometer and a receiving antenna. Just awe-inspiring innovation. So Bose is the first one who experimentally proved what Maxwell earlier said, that light is electromagnetic in nature. I mean, nowadays we just take it as granted that light is electromagnetic, but even when Maxwell told that, it could not be experimentally proved. It was only Bose who proved proved this one, that light is electromagnetic in nature. And how he proved it? It is by measuring refractive index of a quartz crystal using millimeter wave transmitter receiver Quasi optical setup. Now we all know that applications of microwave and millimeter wave are now the basis of the wireless communication around the globe. And J.C. Bose, we can say, is the father of this modern communication, without which the civilized world could not function today. This is just for the purpose of to show the brilliance of the scientific development at that point of time. So J.C. Bose with other prominent scientists from University of Calcutta, and this was at an advanced age of J.C. Bose, you can see, but we can already see in this figure, just three were marked here, that J.C. Bose, then Meghnad Saha, and of course the second Bose, you can see how young he is. And if you know others, you can identify Gan Ghosh, the Gan Chandra Ghosh is there, and others. All brilliant, engineers, technologists, physicists of that time who were all present simultaneously at a particular point of time. But now coming to September 15th, 2012. This is the the milestone dedication ceremony. Then the left side, this photo is showing the dignitaries on the dais in the plaque dedication ceremony. This program was held at Presidency University. And on the right side, you can see at a scale where you can see the entire hall and the dais at the Presidency University on September 15th, 2012. And there was that formally handing over of the plaque. As you can see here, this plaque is being formally handed over to the Vice Chancellor of Presidency University, the then Vice Chancellor, Professor Malavika Sarkar. You can see her. And this is Dr. Peter Staker, the then IEEE President-elect. Now I move on to the second milestone, that is the Raman effect. And this is by Sir C.V.Raman, who was younger to Sir J.C. Bose by 30 years. This is a photo which is in the year 1930 with all the other Nobel laureates after the presentation ceremony. So you can see here C.V.Raman. But now coming to the milestone, that Raman effect 1928, and J.C. Bose was 1895. This was also, as stated, dedicated on the same day, September 15, 2012. Once again, the exact wording on the milestone that IEEE History Committee approved is like this. Sir Chandrasekhara Venkata Raman, Nobel Laureate, Physics 1930, assisted by K.S. Krishnan at IACS Kolkata, India. This is very important. That's look, IEEE not only recognized Chandrasekhara Venkata Raman, but they also recognized the support that K.S. Krishnan provided. Discovered on 28th February 1928, light entered and scattered was of a different color. uh, dependent on material property. This is a very important aspect. This radiation effect of molecular scattering of light bears its name as the Raman effect, from which many applications in photonic communications and spectroscopy evolved. This is the actual wording of the C.V.Raman milestone as approved by IEEE History Committee. On the left is a photograph of the milestone plaque that IEEE provided us. On the right, it is the actual place where at Indian Association for Cultivation of Science, Kolkata, it has been installed. Just a little bit on the historical aspect, that Raman's voyage in 1921. In 1921, Raman traveled to Europe from his home in Kolkata to attend the Congress of Universities of the British Empire at Oxford. But that was not the important aspect. What was the most important was his return voyage. And that time, you all know, it was by ship. So Raman was returning back aboard the SS Narkunda. And this particular voyage would lead Raman to change history. During this sea voyage, he observed the blue opalations of the Mediterranean and wondered what is the origin of this beautiful phenomenon. Of course, Raman was aware of the explanation given by Lord Rayleigh that the color of the sea was due to the reflection of the blue sky, but Raman did not accept it. So, with a polarizing quartz prism that he carried in his pocket, believe me, that he carried in his pocket, he proceeded to demonstrate Rayleigh's explanation to be false. Now, this is something unbelievable, right? That a polarizing quartz prism which Raman carried in his pocket, he proved with that particular thing Lord Rayleigh to be false. He studied the surface reflection of the sky on the sea surface and noted that the blue color of the sea was unattenuated. This was the most significant thing he noted with his that particular polarizing prism. Then, with a diffraction grating, he showed that the maximum spectral intensity was different for the blue sky and the blue sea. At the end of this voyage in 1921, when Raman landed in Mumbai, during that voyage itself, Raman has written 2 papers. So when he landed in Mumbai, he immediately sent these 2 papers to Nature from Mumbai, stating that the color of the sea was due to light scattering by the water molecules, not by reflection of the sky. And he termed this phenomena as molecular diffraction. Thus began Raman's research obsession, the molecular basis of light scattering. This was Raman's actually an obsession later on. So it all started in 21. By 1925, Raman had observed the frequency shifted scattered light in more than 50 different liquids. And by 1927, he had noticed that the scattered light was polarized. So 1921 to 1927, in these 6 years, he was almost obsessed with this research and continually studied and observed interesting things. He described the phenomena, which he called modified scattering, in another paper in Nature. Later, all this will be called Raman effect. This is just again, see, earlier I have shown a figure in Kolkata where brilliant scientists were together. This is a conference of Nobel Prize winners in Lindau, Germany. on the shore of Constance Lake, a very beautiful place in Europe. In 1956, there was a conference where all the Nobel laureates went. And this was just an evening. You see all the Nobel laureates, and you know who is singing? It's the Pauli, Wolfgang Pauli. So just good to see and see how they were all engineering. And this was Raman there. Just behind Pauli is Raman. This is Raman spectrograph. On the left, this is the spectrograph photograph with Raman himself. And Raman was quite young at that time. Raman was born in 1988. So in 1928, he was 40-year-old, 40. This is the, on the right is the Raman spectrograph, which is now available. You can go to Cultivation of Science and see it. And this was the first Raman spectrum was obtained with this particular, again, understand the brilliance of these scientists that with this such absolutely original works were produced. This is just to show the entire type of configuration, all the individual parts from left to right. That means constant deviation spectroscope, nutting polarization photometer, filter, Mercurial clamp, everything was placed on a bench. But please don't ask me all the technical details. I am not the right person to answer all the technical details. But these are the instruments to take spectrum to determine the wavelength and polarization of the scattered light. But this is something very interesting I found, not earlier, but this is quite recently in 2018. If you are interested, you can read this paper. This has been published in Indian Journal of History of Science, 2018, volume 53, number 4, page number 68 to 73. Now, I have taken page number 71 only because this gives a very interesting, the most phenomenal works or the seminal works, these are published in 4 papers. These are these 4 papers, 1, 2, 3, 4. You can see 2 are published in Nature and 2 in Indian Journal of Physics. And they are all in 1928. That's why IEEE milestone was also given, time stamp is given as 1928. But the interesting work they did in this paper is that what are the apparatus or the instrument that Raman used in this sort of work which were reported in these papers. So on the right, you can see the list of the instruments of the apparatus. Very interesting to note this, but I'm not going into details because that will take quite a lot of time. But what is another work they did? This was page number 71. This is page number 72. This is a table showing instruments and their price at that time, of course. So they made a table and all these components, and this is the approximate price in rupees at that point of time. So total cost that came for all that Raman's entire experimentation in 1928 is 7,630 rupees. So Raman made his discovery of Raman effect, which we know that today one Raman spectrometer, how much it costs. So Raman made all this discovery in 7,630. And even if we take the time gap, that means 1928 and 2021, if you take the inflation, this is not a very big amount. I think nowadays our scholars get projects by DST much higher than whatever will be the equivalent money today. Another very interesting aspect that I want to say is visual observation by Raman. Raman, you may know that analysis of light scattered by a liquid is not an easy task. And much of the early work in Kolkata was done by the visual observation of color. rather than precise measurement of light's wavelength. Now that is something so interesting, that visual observation of color rather than precise measurement of wavelength. And most interestingly, Raman used his own dark adapted eyes as photo detectors. Just today we can believe it, this one. Only after he had observed the frequency shift with his eyes, then he used a direct vision spectroscope, and then he repeat the entire thing with a mercury arc lamp and a Helgar baby quartz spectrograph. That's how that all this Raman you typically used to do. But Raman knew that visual and qualitative observations alone would not be sufficient information. So he methodically set out to measure the exact wavelengths of the incident light and the Raman scattering by replacing the observer with a pocket spectroscope. That's what I was saying, that they were not having all those big things. Then he ultimately replaced this pocket spectroscope with a quartz spectrograph. And with the help of that, finally he was able to photograph the spectrum of the scattered light and measure its wavelength. And that is actually this one. This one. This and all these quantitative results which he finally could do, that was published in March 1928. So if you see here, this, I mean, this Indian Journal of Physics, these papers, 1928, these are the papers where he published his quantitative results. But Raman at that point of time understood that the result that he got was much more important than just that scattering. So in his 1930 Nobel Prize address, he stated that the character of the scattered radiations enables us to obtain an insight into the ultimate structure of the scattering substance. That was so important statement. The unique spectrum of Raman scattered light for any particular substance serve as a fingerprint that could be used for qualitative analysis, even in a mixture of materials. Further, the intensity of the spectral lines is also related to the amount of the substance. Thus came into being the Raman spectroscopy that we all know today, which could be applied not only to liquids, but also to gases and solids, and also to analysis of aqueous solutions. The Raman Milestone dedication ceremony, on the left, all the dignitaries sitting on the dais, September 15, 2012 at Indian Association for the Cultivation of Science. On the right is the audience in that program. Then on the left is the handing over of the plaque to the then director of the Indian Association of Cultivation of Science by Dr. Peter Stecker, and the speech that Dr. Peter Stecker made in both the events. He made speech at Presidency University as well as at Cultivation of Science. This entire event was highly publicized in IEEE publications. This is the institute of IEEE where this was very eminently publicized, the first IEEE milestones in India. That was the 7th September 2012 issue that brought out this first IEEE milestones in India, and we are extremely proud that we did it in Kolkata under the leadership of Kolkata section. A very wide coverage we got of the media. As you can see here, these are the Times of India, the Hindustan Times, and all others. I have not taken many others. This is Bengali newspapers. You can see Anandabajar Putrika, Bartaman, Statesman. There are others also. So this was very widely publicized. But what now I want to say is I started with an IEEE map, IEEE milestone map. So now I would like to say that I showed you the map in 2012, but up to 15th December 2020, how many milestones have been dedicated in the world? The answer is 211. This data I have taken from the IEEE History Center's website. You can also see it. Now you can always ask me, what about other IEEE milestones in India? Are there any? The answer is yes. This first top one, that is the giant meter wave radio telescope in Pune, that was first operational in 1994. So that was not as old as Raman or J.C. Bose. All approvals have been received. That means IEEE History Committee, Board of Directors, everything received. And as I came to know from the Bangalore office of IEEE that now a date is being finalized, but because of Corona and everything, this is being deferred because IEEE want this is to be a physical program, not just an online program. The Calcutta Electric Supply Corporation, 1897, that's another very old one. This proposal has been submitted, but this is awaiting decision. What I have come to know that there are a lot of documentation that IEEE wants. And this is Bangalore office is coordinating this one. And as I said that earlier, IEEE milestones, they also honor the organizations where such innovations have taken place. So this is the IEEE CESC as an organization is a milestone. Then invention of semiconductor crystal diode detector, 1901. It was proposed by IEEE Kharagpur section. Again, proposal has been submitted, but this is in the adjudication process. So we are, the decision is awaited. So with this, thank you very much for listening to me. As I said, I am not a technical person in this area, but I tried to project the, historical aspect, some of the brilliance of those people who did it, and what we did in Kolkata in 2012. Thank you very much.
Thank you, Professor Chakravorti, for this enlightening talk. So now let us open it for questions. Anybody has any questions? Anybody in the audience?
No.
Okay, Professor Chakravorti, this is Professor Biswas here.
Yes, Professor Vishwas.
Yes, I think the Pune radio telescope is already installed because I heard something like that. I'm not sure, but I heard that it is installed. I'm not sure 100%.
I can tell you up to last month it was not installed, but
Oh,
if
then
it has,
okay.
then
it's okay. Then it's okay. Because that means what I heard actually was the fact that it is approved. That's
everything has been approved and plaque has been prepared. But as I said, that IEEE wants it a physical program because this is a third milestone in India after almost a decade. So, but as you know, because of this Corona and all that traveling, because typically IEEE either president or president-elect comes for this sort of program. But now they don't really want to travel, from US to all these places.
And plus international travel is also at the moment closed. It's not there. Yeah.
Anybody else? So let us thank Professor Chakravorti for this very informative and delightful talk. So we are greatly enlightened about these events. So with that, I thank you all for having been here. And
Thank you. Nan namaskar. All best wishes to everybody.
Thank you.